for this video, we are going to tackle about trigonometric ratios. For this one, let's have the following discussion. So this is just a review of what we already discussed in class. So let's have the following. Now, let's start with this first one. The first part that we have discussed is about a bit of history about trigonometry. So if you remember in your short test, the one that has been mentioned is Hipparchus of Nicaea. Hipparchus basically says here is the one who made an advancement in trigonometry, especially the table of trigonometric values. So to rush it off, or rather just to give a brief moment of what a right triangle is, we already defined it simply as just simply a triangle in which one of its angles is a right angle, like here, wherein opposite of the right angle is what we call the hypotenuse, or the longest side of the right triangle, and the other two sides that were not mentioned are the legs. Thus, in this particular illustration, AB, or side AB here, is the hypotenuse, and the two legs are namely BC and AC respectively. So with those in mind, let's have the following. We have to draw or redraw this triangle again. There you go. So let's have this as our right angle, and let's name this triangle ACB or ABC, whatever you want to read this. So how we label this, we have to note that each of the opposites of these angles, we name them a side that is smaller, or the letter smaller to it. In this case, opposite of angle C is side C, or we often write as the letter C in the small in the small letter. In this one, the opposite of B here, we write side B as a small letter, and so goes for A, wherein we write letter A in a small case. So if we focus here on angle B specifically, on this one, we know that the side opposite of B, or angle B, is the small letter B. If we focus here, this is opposite, and what the closest side to it is what we know to be the adjacent, and whatever happens, the side opposite of the right angle is gonna be the hypotenuse. But keep in mind, if we have the following illustration wherein let's say we don't focus on B, but rather we focus on A. Let's say A here. So meaning we focus on this angle. Now, on this particular case, A is now the opposite, and B is now the adjacent. But whatever happens, C is still the same, which is the hypotenuse. So for this particular mnemonic, I want you to remember these initials, because this will be useful in remembering these mnemonic. So, ka, towa. Or you will keep on remembering this over and over again. Sokatowa, sokatowa, sokatowa. For this case, these are the three main trigonometric functions, wherein we have S for sine, cosine for C, and tangent for T. And we often follow these three trigonometric functions with the measure angle, or in this case we use theta. And lo and behold, OA and H corresponds to the sides, either it's opposite of theta, adjacent of theta, or the hypotenuse. For so, it's opposite over hypotenuse. For cosine, it's adjacent over hypotenuse. And for tangent, or tangent theta, is going to be opposite of theta over adjacent of theta. We have another mnemonic that is not used often, but you can still use this. It's just choshakao. So if you want to know this, these three other things are just the reciprocals of the respective ones, or the respective trigonometric functions. The reciprocal of sine, in this case, is cosecant, or we abbreviate as CSC. The reciprocal of cosine being secant theta. And the reciprocal of tangent theta is cotangent theta. And looking at the mnemonics again, we have the H, O, and A. So on this particular case, what just happened for the reciprocals is that we get the reciprocals of their outputs. If opposite is in the numerator here, this will become the denominator on this one. And if you see that hypotenuse is in the denominator, the hypotenuse will now be in the numerator, like so. So again, these two are reciprocals of each other's. Same goes for the other ones that I just write. So secant being hypotenuse over adjacent, and cotangent being adjacent over opposite. Now, with this in mind, let's have the following. So I just summarized everything basically. So let's have just one. Let's say I have here A, right? If we focus particularly in A and we want to find opposite over hypotenuse, or what's we known as saw, the opposite of A is the side A, like what we have here. And the hypotenuse is gonna be C, like what we have here. That's corresponding to saw, or the saw of the Sokatawa. Same goes for the other one. So I just summarize it briefly here. And as I said earlier, here are the reciprocals of the following. Sine is reciprocal with cosecant, cosine is reciprocal with secant, and tangent is reciprocal with cotangent. So now you know the basics. Let us proceed. You can pause the video if you want, if this will be useful for you to have a breather to remember everything that you need to know. So with those in mind, let us continue the next few lessons. So next, it's already given here, but let's try to solve the following. Let's just focus on cosine if cosine is indeed correct. So using this information, let's see if cosine A, focusing on A, if you remember cosine, it's ka, right? Wherein cosine theta, or in this particular case, cosine A is adjacent over hypotenuse. Adjacent of A is this one, right? And the hypotenuse is always going to be here. So if we check, indeed 3/5 is the answer. So just to check that it's indeed correct, you can pause the video and answer this for yourself. Moving on to other examples that does not have an answer. Let me verify some of here so that you can still work on this on your own. Let's answer this. So particularly, let's focus on y. And we want to solve for cotangent y. Pause the video if you want to answer this yourself. If you did compute it for yourself, cotangent, if you remember, it's kao, so it's adjacent of y over opposite of y. So particularly, if we focus here, the adjacent of y is r, and the opposite of y being n. So it's r over n. There you go. Here, let's say I have this exercise. Remember that in this particular case, we have sine p is equal to 12 over 13. But we don't know what to do first, right? It's often confusing for others. But I want to suggest first drawing the triangle. And let's set this as p. What is sine again? It's opposite over hypotenuse. Opposite being 12. So opposite of p right here is 12, right? So let's have this. And hypotenuse being 13. So let's compute for the missing side if you want to use it. You can use your calculator for this particular exam. So it's just gonna be 13 squared minus 12 squared, if you remember. So solving for this, you have 5. So now you have your adjacent. Adjacent for 5, opposite of for 12, and hypotenuse for 13. Pause the video if you want to solve for the remaining trigonometric functions, thus explaining this part. And here are the answers. Now, Now, I hope that you understand that part, so that let's move on to another one. Give me a few times to prepare for the next few slides so that I can verify what I'm going to say. With those in mind, let us now have the following. So, let's say now you want to work on the 6 trigonometric ratios given a figure. Let's say here. You have 15, 17, B, A, and particularly we focus on A and B, but for this particular example, let's focus here on B. I want to find, let's say, cosine B. But here's the thing, cosine is adjacent over hypotenuse, but my adjacent side is missing. So let me solve that using the calculator. So it's just simply getting the square root of the square of the hypotenuse minus the square of the other leg, being 15 squared. Let's check. The answer should be 8. So this is 8. Now, if you want to solve for this, now you will get cosine B is adjacent, being 8 over hypotenuse 17. Now you're done. That's it, right? Pretty easy. You can pause again the video for this part so that you will be informed of the next example. So let's have a recap of this. I think I should be discussing this first, although this topic is so out of hand. Let me move a few topics back that I need to discuss that is also included in your test. So let's go back to Pythagorean theorem, just in case. Let's have these slides here. Okay, now. Okay, here. Just for a recap what the Pythagorean theorem says, in a right triangle, it says that the Pythagorean theorem states that if you have C as your hypotenuse and A and B as your legs respectively, the square of the hypotenuse C is equal to the sum of the squares of the two other legs. If indeed this is true, then you will form a right triangle. So if you want to solve for C, you just need to get the square root of A squared plus B squared. But let's say you want to solve for B. So what you need to do here is just move A, right? So particularly you will have C squared minus A squared. And for A, you need to move B to isolate A and get the square root. So it's gonna be the square root of C squared minus B squared. Simple as that, right? Do I need to explain something right here? Okay, I want to explain this problem. So this particular problem, TRIG is a trapezoid with TG being perpendicular to GI. Find the value of x in the perimeter of the trapezoid. So you're being asked of two things: the value of x and the perimeter. Perimeter is just the sum of the sides, but I want you to think of it this way, wherein you can actually draw a line here that is also perpendicular to this one. So if you do so, you can apply the property of a rectangle wherein opposite sides are congruent. Thus, this also has a measure of x. But this part here particularly will not be 15 anymore, because you are getting something from 10, because this particular length is just 10, right? But the whole thing here is 15. So if this is 10, how much is left to make it 15? Thus, you have this part as 5 only, and this will become 10, right? To still make it 15 in a case. And you want to solve for x. Thus, you can apply the Pythagorean theorem, or you can use your calculator again. Just maximize the use of calculator because we are allowing you to use it. So 13 squared minus 5 squared, simply 12. Thus, you have x as, let me put 12 here. And this simply solve for the perimeter. So that you won't be confused, just add 10, 12, 13, and 15. So this part here is 25. So if you add 25 and 15, you have 40, and you still have 10, which is 50. 50 units, because it does not say any units, so we assume that this is units. This one here is actually simple. So on this particular problem, if this is 3, so it means this is also 3, right? And if this is 4, this is also 4. But we don't have a measure of this diagonal, so you can use to set that as x and get the Pythagorean theorem. So if you would like to imagine this as a separate triangle, it will look something like this, wherein this is the right angle, this is 3, this is 12, and you solve for x. And if you utilize this, you will have approximately 3 square root of 15. But you are solving for what is BD. As you can see, this is 3 square root of 15, right? If you draw this triangle here in a 3D sense, it will look something like right angle or right triangle still. This is 3 square root of 15, and this is 4. So you're missing the hypotenuse. So let's set that hypotenuse as y. So meaning, you're just getting the square of 3 square root of 15. Oops, wait, let me do this properly. Squared plus 4 squared. And thus you can solve for the following as, wait, did I get this wrong? It's not 12. Oh, it's not minus, I'm sorry. It's supposed to be plus. So, oops. So there. It's not supposed to be minus because it's already the diagonal. Oops. So this is gonna be 3 square root of 17. And then 3 square root of 17. 3 square root of 17 squared that plus 16, or 4 squared. So you have the answer for y as 13. Oopsie. As 13. Simple as that, right? Now, I will leave this to your discretion if you want to answer this. A Pythagorean triple, I guess that's just a fun fact about Pythagorean triple. I'm just discussing the essential things that you need to learn, okay? Okay, for this one. So, televisions are measured diagonally, right? Define the diagonal length of the rectangular TV with a length and width of 28 inches by 45 inches. But you're finding the diagonal here. In this case, if you want to draw this again, it will look something like a right triangle. Oh, wait. Missing. Wait. Where is it? Okay, there you go. So, if you will draw this again, it will look like a right triangle, right? This will be 45. This will be 28. And you're missing this. You can get this by just using your calculator again. You can actually utilize this very quickly, and you can finish your exam in less than 1 hour. So, x is not equal to 53, and you already have your answer because the measure of the TV is measured by its diagonal. So, you have a 53-inch TV. Case in point. And I think that's it. So, this one is concluded for this one. You can solve for this on your own. You can pause the video again if you want to try solving this on your own. And let's move on to the next part of the lesson, in which we are going to have the special right triangle. So the special right triangle is a tedious topic, to be honest, but once you get the hang of it, you will not get confused by it. So let's try with this one. So start with a 45, 45, 90, right? So you illustrate this triangle wherein you have two 45-degree angle and one 90 degrees, because take note, if you already have a right angle, it means the other two angles in that triangle should be complementary. And what do we define a complementary angles again? Those are angles wherein the sum is 90 degrees. So what's that, right? And just to confirm, if those indeed are 90 degrees, what is the sum of 45 and 45? It's 90, right? So next, I don't want to explain this tedious process because I just want you to remember the mnemonics. So in an isosceles right triangle, the hypotenuse is square root of 2 times as long as either of the legs. So if let's say, I'm gonna give examples spontaneously so that you will be practiced by it, so that you will understand this more and more. Let's say this is a 45, 45, 90. If I have, let's say, 3, what is the measure of this? It's also 3 because they are just the same measure. But the measure of this here is just you multiply 3 or this shorter leg by square root of 2. What is 3 times square root of 2? You're done. 3 square root of 2. That's it. Let me have another example. Let's say, using the same figure, I have now 8. But how do I compute for this? If earlier we multiplied the shorter leg by square root of 2, we do the reverse of multiplication. What is that? Division. Are you done with this? No. If you want to have an easier computation, you can use your calculator for this one. 8 over square root of 2. The calculator will simplify for you. The answer is 4 square root of 2. And both of them have the same measure. But if you want to use the long method, just in case, we rationalize this by multiplying both the numerator and denominator by square root of 2. Thus having 8 square root of 2 over, what is 2 times 2? It's 4. But square root of 4 has a specific answer, and that is 2. 8 square root of 2 over 2. And we can cancel out 8 and 2. That being 4 square root of 2. Thus completing your computation. That's it, right? So easy. I hope that you're still following. You may take some break from time to time by just pausing this video. And now, let's try to answer this. Since you will be using your calculator, might as well maximize it, right? For this one particular example, let's have this. On this particular given, the given is the hypotenuse. So you can just simply divide 6 by square root of 2. Your answer is 3 square root of 2. Thus, both x and y in this particular example is 3 square root of 2. Because both of them have the same measure. And for this size, if you want to divide 2 square root of 6 by square root of 2, you can just simply divide the insides of the radical, thus having 2 square root of 3. There you go. Thus having the solutions 2 square root of 3 for both x and y. Now, let me zoom in again. Ayan, there you go. This was a ballista. 30, 60, 90. Here are the relationship between all the sides, right? Okay, let me have this. This is 30. This is 60. And first and foremost, if you have, let's say, 30, in which the measure is x, right? Oh, there's a figure already on the right. Let's not use that. Let's say we have 1. using the side opposite 30, I want to solve for where is 60. What I just need to do is multiply the shorter side, meaning opposite of 30, by square root of 3. 1 times square root of 3. Square root of 3. And I want to solve the hypotenuse. I just need to reference this shorter side and multiply to 2. What is 1 times 2? It's 2. You can remember this ratio we're in. This is the shorter leg. This is the longer leg. This is the hypotenuse. Yan yung ratio that you can use. Let's say, among all the 3 givens, you have a triangle wherein the hypotenuse is 6. You can use this ratio actually. What is 6 divided by 2? 3. So, meaning you can use a factor of 3 to multiply it to them. What is 1 times 3? 3. What is 3 times square root of 3 times square root of 3? 3 square root of 3. You're done. Nalakabilis. Or, let's say, ang given ko, on this example, I have square root of 6. Now, I want to solve for the other things. If square root of 6 corresponds to the longer leg, I just need to divide this is square root of 3 to get what is the ratio. On this particular one, square root of 6 over square root of 3 is square root of 2. So, meaning, square root of 2 yung shorter leg. I want to get the hypotenuse. I just need to multiply the shorter leg by 2. And you're done. Let's check this. On this example, ang given agad, or the given is already the hypotenuse. But remember, we can divide the hypotenuse by 2. And that corresponds to the shorter leg. Or the one opposite of 30. Pero, on this case, if this is 60, ibig sabihin, this is 30. So, if you divide 16 over 2, the answer is 8. And 8 should be written opposite of 30. So, ito yung 8. But you want to solve for x. So, what you need to do just is multiply the shorter leg by square root of 3. And the answer is 8 square root of 3. And that you're done. On this example, if this is 30, we have 60. But the given is 30. This is very convenient. Ang gagawin na lang natin, for 60, you have to multiply it again to square root of 3. So meaning, you have to square root of 3. And for hypotenuse, you need to multiply the shorter leg 2 by 2. So what is 2 times 2? The answer is 4. Okay, I will answer this one, but you can pause the video if you want to work on this on your own. So now, this is a rectangle, meaning the opposite sides are congruent. This should be 8, this should be 6. Let's use that to compute for the other sides. Now, if this is 30, this should be 60. And this particular side, 30 yung opposite. So meaning, the opposite of 60 is just 6 square root of 3 because we need to multiply the shorter leg by square root of 3. And if you want to get the hypotenuse, you need to multiply 6 by 2. And 6 times 2 is 12. On this one, we have 45, 45, 90. And if we want to solve for the sides or the legs, both of them just have the same measure. You just need to divide 8 by square root of 2. In doing so, you will have this and cancel. You have 4 square root of 2. Both of them having 4 square root of 2. You can use again your calculator if you want to solve for the perimeter. The perimeter is just a measure of the outside or the sides outside of the figure. Let's start with 8, then 6, then 4 square root of 2 plus 4 square root of plus 4 square root of 2 plus 6 square root of 3 plus 12. And the answer is roughly 47.71. You can use that or you can use the radical form. Anywhere goes, I will consider the answer. So let's move on to a more practical way on how we use this. So let's go back to topic 1. So now, you have returned to this particular topic. Let us now go back to this concept. So remember, 45, 45, 90, to get the hypotenuse is just square root of 2, right? So I guess this is so tedious. I don't want to use this table, but I hope you remember this particular part. So you can actually get, let's say, using this comparison, right? It's just saying sine 30 is just equal to cosine 60. Let's check. So meaning, sine and cosine have complementary angles or complementary angles in a special triangle. If we check indeed in the table, sine 30 has the same measure as cosine 60 or the same answer as cosine 60. Because if we check the sum of their angles, 30 and 60 are both 90, right? Same goes for the other angles here. So meaning, if you already find, let's say, sine 30, you can already answer what is cosine 60 using that information. Same goes for the other one. So this will make your table completion much easier. So I already taught a lesson wherein you can use the handshake method if you want to solve for the sine and cosine of a specific trigonometric value. Let's say, imagine this as your fingers. Let's say 0 is your thumb, 30 as your pointer, 45 as your middle finger, 60 as your ring finger, and the pinky finger being 90. If I want to say what is sine 30, first look at where is 30 is. So wherever 30 is, bring that finger down and then look to the left. How many is to the left? How many fingers to the left? That is 1. So replace x with 1. So that will become like this, right? So square root of 1 is 1. And if we check, sine 30 is indeed 1/2. So you can also use the same concept. Using the same angle, cosine, for this one, if you want to solve for cosine 30, bring down 30, or rather 30, and look at the numbers wherein you have 1, 2, 3 fingers up. So meaning, replace that x here with 3. So cosine 30 is simply square root of 3 over 2. See, it's pretty easy. And if you want to solve for tangent theta is just simply dividing sine theta over cosine theta, like so. What else? I guess that's it for topic number 2. Let's move on. Okay, solutions of right triangle. So this is much crucial information that I need to discuss. Hopefully that you will pay attention to this part. So now, let's have this. So without moving anything to the next slide, let's just focus on this. Okay, example 1. I have 2 parts given wherein I have 12 degrees for A and 20 millimeters for side B. So if I want to solve for the rest, I can use this, right? Remember what I said earlier, that the sum of the 2 other angles, if we already have 90, is that the sum of the other 2 remaining angles should be 90, right? So if that's the case, then it must mean that we have to subtract 90 and 12 to get the measure of B, right? So if we do so, 90 minus 12 is 78. So this is 78 degrees. Now, you want to solve for the others. Without referencing anything and just using this, we can actually use the triangles, or rather the trigonometric ratios for this one. So let's focus on these 2. These as our angle, this as our side. With relation to this one, What is the side corresponding to angle A? If you answered it's adjacent, you are correct. So, very good for this part. So, let's set this as adjacent. Now, we just need to find among Sakatawa, which is mentioned opposite together with adjacent, and which is mentioned at hypotenuse together with adjacent. Now, let's try to solve the opposite side first with respond to A. So, among Sakatawa, I'm gonna write Sakatawa. Sakatawa, on this case, let's have this. So, if I want to solve the opposite side among Sakatawa, which is mentioned both adjacent and opposite at the same time, it's tangent. Okay, very good. So, let's use tangent. Tangent A is opposite over adjacent. Now, let's replace everything that what we have right now. So, tangent of A, or the measure of A in this particular case, is 12, right? And opposite being A, or the missing one, let's set that as X. And, or rather, more appropriately say, let's just write A. And adjacent being 20. I'm going to teach you, everyone, that I didn't teach in class. If you really paid attention to this video, I will teach you how to use shift solve. Okay? I will now start to use this moving forward to see if you really watch the video, because you will learn a lot from shift solve. So now, pay attention. If you're a fellow student of mine, use a wave emoji so that I can know that you are watching the stream. And yes, I am streaming this right now. Or rather, if you watch this, I am done streaming. So anyway goes. Here is the following. Now, as you can see here, we have tangent 12, right? So I want to type tangent 12 as is. And now I press alpha and press this calculator button so that I have equal here. And input this and press alpha again and press on this close parentheses to make X over 20. And now once you are done with this one, press shift again and then calculate, or you will have the solve. And when you press equal, you have your answer, in which the answer for A is equal to 4 point, or rather approximately equal to 4.25. Instead of you using the tedious method wherein you have to manipulate this, wherein multiply 20, this is just equal to A is equal to 20 tangent 12. But let's see if 20 tangent 12 is equal to this one. So let's see. If 4.25 is still the answer, then 20 tangent 12 should be the same, right? Let's see. There you go. They are the same. I have just taught you a really cool calculator trick. I hope that will be useful in the future. So now we have this. Let's replace this with 4.25. But now, what we are missing is hypotenuse. So let me clear up this one. Without using this opposite, what is the trigonometric ratio wherein adjacent and hypotenuse is mentioned at the same time? It's cosine. Very good. So using cosine A is adjacent, wherein we have the value over hypotenuse being C. You can also use your calculator again to do the following, where cosine 12 is equal to 20 over C. Let me use this again, the trick that I just taught you. So input cosine 12, press alpha, then calculator, or calculate to have equals. And then input the fraction wherein you have 20 over alpha, then close parentheses for x, then shift solve. Then the value should be approximately, that C is approximately 20.45 millimeters. I hope you understand this part. Now, I think we are already done. We have already solved everything that we need to know. So 20.45 millimeters. Thus, we complete the triangle. I hope you understand this part. Now, I just taught you a really cool trick and calculator. You will not have trouble to solve for this one. So, another one. You can actually apply the same concept of the ship solved thing to this one. Let's use this example. If you want to solve for this angle, if we focus on A, what is the side? What is 2? Is 2... Wait, let me find this example again. I'm lost. There you go. On this particular figure, what is 2? Adjacent, opposite, or hypotenuse? That is indeed opposite. What is 3 with respect to x? That is our hypotenuse. Very good. Among the 3 trigonometric functions, what is mentioned here is very good. So we are going to use sine function. So meaning sine A is equal to opposite being, if we write the letters, opposite of A is the small letter A, right? If you remember. And hypotenuse is always the opposite of the right angle, which we write in small letter C. And we just replaced it with what we have right now. So sine of x is equal to opposite 2 over hypotenuse 3. And I mean, right now you can simply it's much better if you just compute it normally instead of using ship solve. But let me do the same thing. So remember, when you want to compute for arcsine, it will look something like wherein we convert this particular equation. If we want to solve for x, we use arcsine of 2/3, or in your calculator it will look something like this: sine raised to negative of 2/3, wherein now you press shift then sine, then input your fraction, in this case this one. Thus the answer is approximately x is 41.81, or in some particular instruction we round it to the nearest degree. Thus we use x is approximately 42 degrees. Some instructions said we to the nearest degree. If it says to the nearest degree, do it this way. If it's nearest hundreds, round it off to the nearest 2 decimal places. But if you really want to find out if the thing that I just taught you also works on this one, it looks something like sine alpha x, close this parentheses, alpha equal to 2 over 3. And ship solve, you will also get the same answer. Pretty neat, right? Once you have learned this, nothing can stop you from using your calculator. So, yeah. That is the one thing that I did not teach in class. But if you are really watching this video or this stream, you will learn a lot. So, up to you. Let's try to solve. Okay, example 1. I choose to just let you answer example 1 on this case, or in particular just one section rather. So pause the video if you want to answer this on your own first before we proceed with this one. So now, without using the other values, once we solve this, let's focus on B as our particular angle. If we have this B, what is this? This is our adjacent. Very good. But this one, what is this? This is our opposite. So let me delete this real quick. And this one particularly is the hypotenuse. Now, without using the values once we solve the hypotenuse and opposite, let's just refer to the adjacent and angle B so that we can solve for the others, right? But lo and behold, let's solve for A first. If we have 35 here, what is this? Again, those two angles are complementary. So if you want to solve for one of the angles, just subtract it from 90. What is 90 minus 35? The answer is 55 degrees. Thus this is 55. There you go. Now, my goodness, I hope that you answer this properly, or just remember this method, please. I'm just begging you guys. But anyway, now, let's just refer to this. I want to solve for opposite again first. What is the trigonometric ratio wherein adjacent again and opposite is mentioned at the same time? Exactly, that is tangent. So let's use tangent. Tangent of B is equal to opposite being B over adjacent being A. And let's replace what we have right now. So tangent B is opposite. Do we have a value for B? So wala pa. But we have a value for angle B, which is 35. So let's just keep B as is, and we have adjacent, which is 11. Now, if you want to solve this on our calculator in the very easiest method, we do this. Tangent 35, close this, alpha equals, since we don't have B yet, let's set that as x over 11. And then shift solve equal. Now, you have your opposite, which is 7.70 centimeter. Okay, centimeter. Now, using angle B and the side adjacent to it, how do I solve for the hypotenuse? In which trigonometric function is adjacent and hypotenuse mentioned at the same time again? Exactly, that is cosine. So cosine B is equal to adjacent being A and the hypotenuse being C. Replace everything what we have right now. Cosine 35 is equal to adjacent being 11 over hypotenuse being C, because we don't have that yet. And the trusty calculator says cosine 35 is equal to adjacent, which is 11 over x, because we don't have C yet. So shift solve equal. Thus, we now have the hypotenuse as approximately 13.43 centimeter. And with that, you are already done. Pretty easy, right? Example number 3. So now we are solving for angle. So if you look at this particular example, the opposite is this one, because it's literally the opposite of x. And this is hypotenuse because it's the opposite of the right angle. And this is adjacent because it's the one closest to the angle. So meaning we have a given for both opposite and adjacent. What is that? Tangent. Very good. So tangent of A is equal to opposite over adjacent. Now, tangent x is equal to opposite being 15 over adjacent being 10. And simply solve for x as arctangent of 15 over 10. And now we use our calculator again to shift tan or arctan on this case, 15/10. Thus, our answer is approximately x is equal to, or approximately 56.31 degrees. Or if the instruction says round up to the nearest degree, it's gonna be approximately 56 degrees. There you go. There's sometimes a good question. And sometimes when I solve for these measures of right angles, do I still use secant, cosecant, and cotangent? Much better that we just use the three main functions. We only use those cases if in extreme cases wherein we are being asked explicitly what is secant, cosecant, and cotangent. But for this particular examples, we do not need to, because it's much better if you use the main tree, because it's much better to let's say it's much better to remember Sokotowa, right? You just keep on saying Sokotowa, 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 and you will already remember what that is. So now let's move on to the application. So I think this is the last part. So upon making an angle of 60 degrees with the ground to the wall and the tip touches the ground 3 meters from its foot, what is the length of the pole? Express the answer to the nearest 100. Now, if this is a pole right here, oops, wait, there you go. Let me click here real quick. So if this is the pole right here, and this is the wall, we already remember that the wall is always perpendicular to the ground, wherein we form a right angle here. And it says here that the pole, or the tip of the pole from the ground, is just 3 meters away from the wall. That's why we have this. And it makes a 60-degree angle to it. You are being asked, what is the length of this pole? With respect to 60 degrees, what is 3 meters? Adjacent, opposite, or hypotenuse? It's adjacent. Very good. So it's adjacent. With respect to this particular figure, what is x? It's the hypotenuse. So if you remember Sokotowa, it's mentioned that in cosine, both adjacent and hypotenuse is used. So cosine 60 is equal to adjacent being 3 over hypotenuse of x. So if you want, you can use again the calculator to just input everything. So cos 60, close parentheses, alpha, solve or calc to make equal up here, then do the fraction 3 over x, and then shift solve. There you go. You have your answer of 6 meters. Thus, the answer is 6 meters. So easy, right? But if you want to answer in full sentence, the height of the pole, or rather the length of the pole, is 6 meters. Now, let's have this. Keynote. And you know what? Let me move to this part. There you go. Angle of elevation and angle of depression. Always remember, it's gonna be an acute angle, no matter what. Acute angle. What is an acute angle? It's an angle that is greater than 0 but less than 90 degrees. So remember that part. Now, so if angle of elevation is just always the object is up. So if you're looking up, it means this particular example is the elevation. With respect to your horizontal line from where you are, if you look up, that is your line of sight. And the angle formed between the horizontal line and the angle of sight is now your angle of elevation. Now, let's say a building casts a shadow of 110 feet. Usapang shadow, or rather, you're talking about shadow, thus it's this one, right? No shadow is looking like this. It's always gonna be like this. Now, so if we are going to refer to this particular figure, um, correction here, it's not 290, it's 29 degrees. So if the angle of elevation from the top of the building to the tip of the shadow is 29 degrees, it's this one. What is the height of the building? You're being asked what is this one. So let's put X here. Thus, with respect to 29, what is this? What is this side? It's opposite. With respect to 29, what is this side? You have adjacent. And you are going to use, there you go, tangent. Meaning tangent 29 is equal to opposite being X and adjacent being 110 feet or 110 respectively. If you want to use your calculator again, is tangent 29 is equal to, set that missing as X over 110. And shift solve. Your answer should be approximately, the height of the building is 60.90. Okay, there already is the answer. I already spoiled it technically. So yeah. Next. Suppose that when an angle of elevation to the sun is 63.4, a building casts a shadow of 37.5 feet. How tall is this building? Let's set that as X. Again, the given is the opposite one of the angle and the adjacent. If you want to solve this manually, or rather using a calculator, rather, not manually, opposite, or rather, we apply tangent. 63.4 is equal to opposite over adjacent 37.5. Shift solve equal to is approximately 74.89 feet. Let's see if the answer is correct. Okay, there. The answer is correct. 74.89 feet. Next. A ladder leans against a 6-meter high wall and reaches the top. If the ladder is inclined with the ground at an angle of 60 degrees, how far is the foot of the ladder from the wall? So, using this illustration, you're being asked how far is the foot of this ladder to the wall. So this is the missing one. So this is the missing one. So let's all set that as X. If we have this is indeed opposite. And this is again adjacent. Same thing. TOA ulit. Tangent of 60 is equal to 6 over X. Use your calculator. Tangent 60 is equal to 6 over X. Your answer is approximately 3.46 meter. So easy, right? Once you get the hang of it. Now, again, a string of a kite is 100 meters long. So meaning, in a real life sense, this is the string. That one that I just draw. So this is 100 meters. And it makes an angle of 60 degrees with the horizontal. You are being asked what is this particular height. So let's set that as X. This time, the one that we are founding is opposite of 60. But what is 100 meters? 100 meters is our hypotenuse. Very good. So now, if we have opposite and hypotenuse, what is that ratio? It is indeed sine. Now, sine 60 is opposite being X over hypotenuse being 100. Now, again, sine 60 is equal to opposite being X over hypotenuse being 100. And thus, you can solve that the value of the height is approximately 86.60. What is the legend? Meters. There you go. Okay, the last part being angle of depression. So now, the angle of depression is an acute angle again, wherein now the object is located below the observer, so that the observer's eye is looking down on that object. So now, always remember again, the angle of elevation and depression is both acute angles. Always remember that. Okay. Now, Bon voyage. From a lighthouse 250 feet above sea level, a ship is spotted with an angle of depression of 8 degrees. So we set this as 8. But like the ship, or rather this lighthouse, is 250 feet far. We can actually vision this. We can draw this triangle this way, right? But like the angle or the angle of elevation will look something like that. Wait, let me connect this properly better. So there you go. So if we make this particular figure, will look something like this. So this will still look like a triangle, but do you agree for some reason that the measure of this angle is also 8? Let me explain how. So remember this concept. This is a topic in grade 8 mathematics, wherein if you have two parallel lines cut by a transversal, it means that the alternate interior angles have the same measure. Let's say if you have 50 here, the measure of this one is also 50. And what happens here, if these two lines are parallel and this is a transversal, this is a transversal, there you go. This is a transversal, meaning these two angles share the same measure because they are alternate interior angles. Thus, if we have point A to B, the angle of depression point A to B is equal to the angle of elevation from B to A, which is a very good analysis of this figure. So now you can also envision this wherein this is 250. You are solving for how far this is. So if you have, let me draw this triangle here. There you go. If you have 250 as your height and you are solving for x, and this is 8 degrees. With respect to 8 degrees, what is this? This is the adjacent. And this one is the opposite. So if you have opposite and adjacent, you will use tangent. Thus, you can solve tangent 8 is equal to opposite being 250 over adjacent being x. So tangent 8 is equal to opposite being 250 over x. Ship solve. There you go. So now if we check our solution, it is indeed 1,778.84 feet far out at sea from the lighthouse. Let's have this one. Now, from the top of the tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. So if you believe this is 40, you can also assume this is also 40, right? Now, based on what we have discussed earlier. So now, if this is 40, if the tower is 45 feet, 45 feet, how far is the partner from the base of the tower? You're being asked this distance here. So if this is opposite and this is adjacent, we are using again tangent. Tangent 40 is equal to opposite over adjacent. Tangent 40 is equal to opposite Oh wait, I did not put the fraction. Opposite over adjacent, then shift solve. So the answer for x is approximately 53.63 feet. So how far is the partner? The partner is 53.63 feet away from the base of the tower, as said here. You can pause this video if you want to solve this on your own, or refer to the slide that I gave you. Now, you're being asked, what is the length of the y here, x, connecting point A to B, wherein it makes an angle of 79 degrees and it's 15 feet away from the pole. If with respect to 79 degrees, this is adjacent and x is the hypotenuse, being the opposite of the right angle. Now, adjacent and hypotenuse, that is cosine. Cosine 79 degrees is equal to adjacent 15 over hypotenuse x. Thus, cosine 79 equal adjacent being 15 over hypotenuse. Here, shift solve, answer. The answer is approximately x is approximately 78.61 feet. Now, I think this is the last given. But after this, let me search for a much harder topic so that I can include it in the future, so that you can also think this on your own. Now, nest. Michael plants a new tree and attached to a guy wire to help support the tree while its roots takes hold. An 8-foot wire is attached to the tree and to the stake of the ground, which is here. From the stake, what does it say here? From the stake, a guy wire makes an angle of 42 degrees with the ground. Find to the nearest tenth of a foot the height of the connection of the point to the tree. So you're just solving what is x here. If with respect to 42, this is opposite and this is hypotenuse. Now, this is sine. Sine 42 is equal to x over 8. Just solve for x by just simply multiplying 8 and sine 42. If you compute this in your calculator, 8 sine 42 is equal to 5.35, or approximately 5.35 feet. There you go. And that's it. I hope that you have learned a lot from this video. So, let's answer this. Here are some complex problems that you can work on your own. So, let's try to answer number 1. Pause the video if you want to answer this first by yourself. And with that said, let us begin. Number 1 says here that a building casts a shadow that is 40 meters long. How wide is the building if the angle of elevation of the sun is 60 degrees? Actually, could solve this using two concepts wherein you can either use special triangles or the trigonometric functions. Because the shadow, again, is this length, right? The one here in the bottom. So let's set this as 40. And if we are being asked what is this height, so it's this one, right? So let's set this as x. If the angle of elevation is here, because we are looking at the sun right here, let's say this is here, so the angle is 60. But again, what is this angle? If we already know this is 90 degrees, the sum of these two should be 90. So this is 30. If we already have the opposite of 30, or rather the shorter leg, if we want to solve the longer leg, just multiply 40 by square root of 3. Very good. So 40 square root of 3 meters. That's pretty easy, right? Let's move on to the next problem, wherein we don't have a special rectangle. On the top of a mountain 100 meters high, Fidel saw a girl who is at the foot of the mountain. So, how far is the girl from the mountain if the angle of depression plotted by Fidel's line of sight with the horizontal is 48? So, if it looks like we are having an angle of depression, so meaning the person must be on top. So, let's imagine this here. This person is here, and the angle of depression is 48, right? And we also have another given wherein the height of the mountain is 100 meters, so meaning is this one. But we are being asked how far are these 2 points, meaning how far is the girl that this person saw. Let's say ito pala, sorry. How far is the other person that Fidel saw, the girl here, from this mountain? So let's set that as x. So if these two lines are parallel, we can also assume that this angle here is 48. With respect to 48, this is adjacent, this is opposite. So you can use tangent. Tangent 48, opposite being 100 over adjacent being x. If you want to solve for x, you can use your calculator. Tangent 48 is equal to 100 over x. Solve equal. That's indeed correct. The answer is x is approximately, let me write it here. X is approximately 90.04 meters. Very good. So meaning the girl from the mountain is 90.04 meters away from the foot of the mountain. There you go. Next. A point is 160 meters from the base of a monument. So we are talking about a monument. Let's assume the monument is like this. I'm not good at drawing, but let's assume, you know what, just a straight line. Fine. So this is the monument. But you're being asked, or rather we already have a given wherein a person, let's say the person is here, is 116 meters away from a monument wherein this is the monument. If it makes a 67 degree with the ground, so it's angle of elevation. So you are being asked, what is this height here? Let's set that as x. With respect to 67, this is adjacent. With respect to this one, this is the opposite. Thus we are solving for tangent. Tangent 67, or TOA, is equal to x over 116, or just simply get x is equal to 116 times tangent 67. If you want to do this on your calculator, 116 tangent 67 is equal to approximately, the height is now approximately 273.28 meters. There you go. It's still easy, right? Now, I want to leave this problem for as an exercise to you. Okay, with that said, let us move to this one. You can also do this as your exercise if you want to solve this on your own, as well as this problem. Basically, I'm leaving the other problems to you guys so that you can do this independently as well. But let me explain this last problem that I pasted here. So let me read the problem. Two walls are situated such that they are parallel. A 20 meters concrete is placed so that it is inclined to the ground at 30 degrees. And it touches the tops of the two walls. If the shorter wall is 25 meters high, how far apart are the walls? How high is the other wall? Here is a tricky question now. Now, Meaning, let's say we have this problem, right? We have two walls wherein they are parallel to each other, but it says here this is a type of two walls wherein although they are parallel, one is longer than the other. Because it says here a 20-meter concrete is placed so that it is inclined to the ground at 30 degrees, and it touches the top of the two walls. So meaning, if these two are the top of the walls, if we connect this line here, it means this line is now 20 meters. And if I draw this line here, you can still form a right triangle wherein it says here it is inclined at how many degrees? 30 degrees. Now, if the shorter wall in this wall here that we have right now is 25, how far apart are the walls? So we are being asked, what is this measure here? We can either set this here, or rather x, in which this is also x. Know why? Because since these two are indeed parallel, these two are also parallel, in which we can form a parallelogram wherein opposite sides are congruent. Thus, this part here only is 25. But we don't know yet the other answer because we are only answering, or rather, we are answering two things. How far is this wall and how high is the other wall? Because we only have 25, we don't know this one yet. Let's set this as y. Now, let's try to solve x first using this one. Let's just focus on this triangle. With respect to 30, what is x? That is our adjacent. And with respect to 20, that is our hypotenuse. Thus, if we want to solve for x, we are going to get exactly cosine. Cosine 30 is equal to adjacent being x, our missing one, over hypotenuse of 20. And if we want to solve for x, it's just simply 20 times cosine 30 degrees. Thus, 20 cosine 30 is equal to 10 squared of 3. Thus, we already answered the first part. How far are the walls? How far apart, rather. How far apart? It's 10 square root of 3 meters. We are left with one more question. How high is the other wall? We don't have a value for y, but we can solve that in terms of 30 degrees and 20 meters. If we use this information, y is our opposite and 20 as our hypotenuse. So we can use sine. Sine 30 is equal to opposite being y over hypotenuse being 20. And if we want to solve this, sine 30 is equal to opposite, which is y over hypotenuse. Wait, I want to use x so that we're consistent. X over 20. Then shift solve, the answer is 10. So meaning, this is 10. But we need to add the other length of the wall so that we know what is 25 plus 10. That is indeed 30 meters. Oh wait, simple math, I cannot even solve that. 25 plus 10 is 35. There you go. Now, we have answered the two problems and thus completing our solution. I hope you have learned something from this. Thank you for watching this video on your free time, and I hope you'll get a really good score in your midterm examination. And with that, thank you.